Welcome back. In today's class, we will learn about direct variations and inverse variations. Say if we have two quantities and with the change of one quantity, if the other quantity changes or varies, then this phenomena is called variation. If one quantity increases, then the other quantity may increase or may decrease. Based on that, we have two classifications, direct variation and inverse variation. We will start with direct variation first. We know that a cat normally has 4 legs. Now, if we increase the number of cat by 1, that means 2 cats in total will have 8 legs. Now, if we increase the number of cat by 1 more, then now we have the number of cats is 3. So the number of legs will be increased by how many? It will be 12 legs. So what we can see here that the number of cat, this is one quantity, one parameter, and the number of legs, that is another quantity or another parameter. So as the number of cat increases, the number of legs also increases. Now suppose if we have 3 cats initially, and then that means 3 cats will have 12 legs in total. And now if we decrease the number of cats by 1, now if we have 2 cats, then total number of legs will be 8. Now if we further increase the number of cat by 1, then the total number of legs will be 4. That means when we are decreasing the number of cats, the number of legs is also decreasing. So this is what the concept of direct variation is. That means we can say that if two quantities are linked in such a way that an increase in one quantity leads to a corresponding increase in the other, and vice versa, means a decrease in one quantity leads to a corresponding decrease in the other, then such variation is called direct variation. As for example, we can take another example, like we know that when a car travels, it travels with a speed. Now that speed may remain constant, or it may increase or decrease, and within a given period of time it travels some distance. Now suppose if we increase the speed of the car, what will happen? Within that given period of time, the distance that will be traveled by that car, definitely that will be increased as the speed has been increased. So this is direct variation. As the speed is increased, then the distance covered by that car within a given period of time, that also increases. So this is an example or good example of direct variation. Now if suppose two quantities A and B are in direct variation, then the ratio of A and B is always constant. So that is the criteria of direct variation. The ratio of two quantities will be always constant. So that we should keep in our mind when we will be solving exercises based on direct variation. If one point of time their values, means the values of A and B, these quantities are A1 and B1 respectively, then this ratio A1 by B1, what we have learned is that is constant, always constant if they are in direct variation. So that constant is here denoted by K, and that is the constant of proportionality. Now again of those two quantities A and B, if suppose at another point of time, if their values are A2 and B2, their values have been changed. So the ratio of A2 and B2 will be what? Again that ratio of A2 and B2 will be constant, and that will be the same constant K, and that's what it has been represented here. So we can say that the ratio of A1 and B1 will be equal to A2 by B2, means the ratio of A2 and B2. Now if we cross multiply, then it will be A1 B2 will be equal to A2 B1, right? Now we can again think this way, that A1 by A2 will be equal to B1 by B2. Now here what we have done, here we have taken the ratio of the same quantity. Initially it was the ratio of two different quantities A and B, so it was A1 by B1 and A2 by B2, and that was equal to K. Now here we have another criteria, that is the ratio of the same quantity having two values will be equal to the ratio of the other quantity having its own two values. So we can conclude this way, that if two quantities A and B are in direct variation, then the ratio of any two values of A is equal to the ratio of corresponding values of B. So it could be any two values of A, and then the corresponding values of B we have to take. Now this direct variation we will understand by a simple example where we have like a person A, he or she can type 600 number of words in 30 minutes. So this is one quantity where we have the number which represents number of words, and that number of words are typed in 30 minutes of time frame. Now suppose if we want to know that in 5 minutes by the same person how many words will be typed. So what we will do, we can use this relationship where first we will take the ratio of the same quantity. So here the same quantity means number of words, that is one quantity, and time, that is another quantity. So we can write this way: 600, that is one value, and x, that is the another value of that quantity, and that ratio is the ratio of 30 divided by 5, the corresponding values of the other quantity. So from here x will be what? X is the variable for which we don't know the value. So it will be 600 multiplied by 5 divided by 30. So it will be how much? 20 multiplied by 5. So it will be 100. That means in 5 minutes the same person will type 100 words. And this is how we find any unknown value of one quantity which is in direct variation with the other quantity. Next we will learn about inverse variation. Now here suppose we have 5 cakes and on day 1 we are eating 1 cake. So each day we will be eating 1 cake. So initially we had 5 cakes and on day 1 we already have eaten 1 cake. So on day 2 how many cakes we will have? We will have 4 cakes. Now on day 2 also we will be eating 1 cake. So on day 3 how many cakes we will have? We will have 3 cakes. Again on day 3 we will be eating one more cake, and on day 4 we will be having 4, and again we will be eating one more cake on day 4, and on day 5 we will be having only one cake. And then if we eat that cake also, then on day 6 we will be left with no more cake. So what we have seen here, if we suppose the number of cakes, if we represent that as one quantity, and the day that we represent as another quantity. So what we can see here, on day 1 when the day that value was 1, the number of cakes was 5. As we are increasing the day value from day 1 to when we are moving to day 2, as we are eating one cake each day, so the number of cakes, that number is decreasing by 1. So when the number of cakes, that value is decreasing, on the other side the day number, that is increasing. So can we say here that with the variation of one quantity the other quantity varies, but how it varies? When one quantity decreases the other quantity increases, and vice versa. So means if we increase one quantity then the other quantity will decrease, and that is what inverse variation is. Now we will understand this concept mathematically. So we can say that if two quantities are linked in such a way that an increase in one quantity leads to a corresponding decrease in the other, and vice versa, means a decrease in one quantity leads to a corresponding increase in the other, then such variation is called inverse variation. Crystal clear? Now again we can understand this by an example of car. Again, suppose a car is traveling with some speed, and now if the speed increases, then to cover the same distance the time that will be taken by that car will be less. That means when the speed increases, then the time taken by that car to cover the same distance decreases. So here the variation is inverse. One parameter, one quantity increases and the other quantity decreases. So this is also a good example of inverse variation. So we can say now that if two quantities A and B are in inverse variation, then the product AB of the two quantities always remains constant, and this product AB is called the constant of variation, and this constant is in case of inverse variation. So this is the criteria of inverse variation. Now suppose if we have two quantities A and B, and at one point of time if their values are A1 and B1, then what is the criteria? That product of those two quantities at any point of time will be constant. So we can say A1 B1 will be constant, and that is again represented by some constant term K here, and that is the constant of variation. Now suppose of the same quantities at another point of time, if their values are A2 and B2, so their product will be constant, means A2 B2 will be constant, and that constant will have the same value, and that is K. So we can conclude this way that A1 B1 will be equal to A2 B2. Now again we can conclude further that A1 by A2, which is the ratio of the same quantities of two values of the same quantity, will be equal to B2 by B1. This time it's not B1 by B2 what we have seen earlier in case of direct variation. This is B2 by B1. This is inverse ratio of the other quantity, means of two values of the other quantity. So that is another conclusion that we can draw. So we can say that if two quantities A and B are in inverse variation, then the ratio of any two values of A, means of one quantity, is equal to the inverse ratio of corresponding values of B, means the other quantity. So that is the condition that we will always use to solve a numerical or exercise related to inverse variation. Now here we have a simple example where the number of workers is one parameter and the time, that is another parameter or another quantity. Here the problem is like a job is done by 100 number of workers in 10 days. So that is one value, or you can say this is the value of A and this is the value of B, means A1 and B1 at one point of time. Now we have to find that if we want to complete the same job in 4 days, then how many workers we need. So at another point of time, or we can say another set of values of A and B. So here if when the value of B is 4, means B2, what will be the value of A2? So this is the relationship that we will be using. So here first we will take the ratio of A1 and A2. So 100 is A1 and A2 is not known to us, so that has been assumed by some variable X. So it will be A1 by A2 means 100 by X, that will be equal to B2 by B1. So first we will take the value of B2, so corresponding value is 4, and then B1 which is 10. So what will be the value of X then? The value of X will be 100 multiplied by 10 and then divided by 4. So it will be 25 and then multiplied by 10, so it will be 250. That means to complete the same job in 4 days we need 250 workers. So what we have seen here, that when we want to complete a job by 100 workers in 10 days, and if we decrease the number of days, definitely to complete the same job we need more workers. It is in inverse variation, and that's what we have seen here, that when we are decreasing the number of days, the number of workers is increasing. So this is the concept of inverse variation. So I hope this concept is clear to you. In the next class we will be solving a few numericals based on variation. With this I end today's class. Have a good day. Thank you.